Okay, stats, let's try some recordings. I know we already went through some of these examples, but I want to just go through these for a t-test, talking through some of these examples. On the right side, you can see the math. So if we go back through these two examples that we already went through, in this first one, we have 25 people doing a study to see whether trivia improves, keyword, test scores in our psychology course. The mean of the sample scores was an 84. Sum of squares is 528. Population mean is assumed to be 80. And the alpha was 0.05. If we make our way over here to the right side, you can see that I've put the formulas up in the top right. S squared is variance. So we're going from sum of squares to variance. And then from variance, you can go straight from variance to the estimated standard error. Or you go from variance to sample standard deviation, and then to the estimated standard error. I'm going to use this one just for simplicity. From there, you go to your t-test. Okay, so if we pull out, and I already did this at the top here, the important information. We know there's 25 people, so our DF is 24. We know that our population mean is 80, our sample mean is 84, sum of squares is 528, alpha is 0.05, and it's one-tailed because it improves. We go to our t table to find our t critical using a DF of 24 and the alpha and one-tailed, we get 1.711. And if we go through these four steps, the hypotheses, it's equal to 80 is our null. It's greater than 80, given that it's increased and it's a one-tailed design. The critical region is anything above 1.711. Our variance, moving to step 3. Sum of squares is 528 over n minus 1 is 24, gives us a variance of 22. We throw that all in a square root over 25 is n to find our estimated standard error of 0.94. Take that estimated standard error, put it on the denominator here of our t-test, 84 sample mean minus population mean of 80 over 0.94, we get 4.26. And then stating our conclusion, we would reject the null. We would say that the trivia does significantly improve test scores. T parentheses 24 equals 4.26. P is less than 0.05. Okay. We do this again for the next example. This time we have 50 males doing a study testing whether a 10-week walking intervention led to weight loss. The average person lost 2.5 pounds in the 10 weeks with a sum of squares of 419. Compare that to weight loss within the population of 0 pounds using alpha 0.01. So again, over here on the right side, taking the liberty of pulling out the important information. N is 50. Population mean of 0, sample mean of 2.5, sum of squares of 419. Again, it's one-tailed. We're talking about weight loss, not is there a change in weight. Alpha is 0.01. Go to our t table. T critical technically has a DF of 49. I used 40 and got 2.423. Null alternative similar to above, equal to, and then greater than for the alternative. If it's above 2.423, we're going to reject. You can see down here, I found variance using 419 over 49. Variance is 8.6. Throw that all under the square root over n. You get an estimated standard error of 0.41. And then our t-test is 2.5 minus 0 over 0.41 to give us 6.05. Again, that is beyond 2.423. So we reject the null and say the walking intervention leads to significant weight loss, comma, t, parentheses 49 equals 6.05. P is less than 0.01. Okay. Those are just two quick examples to take us through the t-test.